Assalamu alaikum warahmatullahi wabarakatuh. Sat Sri Akal, Namaste, good afternoon. And this is Mansoor Mirza. I am joining all of you again with my free for all mathematics classes for grade 9 and 10. Today, my topic, as you see on the screen, is constructing our lines and curves are the best fit. And this means that when we plot the different coordinates on a graph paper or on paper or sketch these numbers, then sometime we see a pattern and we see some kind of sequence or some kind of relationship between those numbers. And when we try to plot those graphs and lines, that will give us some kind of clear message, trend, as we discussed in the last session. So those trends we can easily find out when we plot these graphs. So today I will be discussing in this lesson today that how we construct these lines, and when we construct these lines, uh, how we find out the best fit, the line or curve which come up after we plot these numbers. So let me explain to you that in linear equation, as remember last Sunday, I explained you the linear equation is which gives you a straight pattern, a straight line as a result of plotting those dots or plotting those coordinates, x and y coordinates. When we see a pattern of straight line, we declare them as a linear equation. And when we see any kind of other curve or any other shape of the final outcome, we declare them as non-linear equation or relations. So linear equations are sometimes the points of a linear relation do not form a perfect straight line, but we can see that when we draw the line for the best fit on the scattered plots to represent the average of the data as we follow the pattern, we draw the line of the best fit by setting our ruler such that it goes through the middle of the pattern formed by the points. An even number of points will ideally be above or below the line drawn. So this shows that when we draw those dots and we see a pattern coming up, we sometimes notice that not all of them are exactly giving us a straight line, but we try to find out the majority, at least more than two or three dot, which gives us some pattern. And if the other ones are scattered, but there are, some of them are giving us a straight line, or majority of them where those dots are giving us a straight line, then we can easily see that yes, this is going to be a best fit. So the reason we call it best fit is that yes, there are some of the coordinates which are not exactly coming on that same line, but we can declare them looking at the final results that yes, there are majority of the points coming on these numbers. So just to give you an idea what I am actually talking about is I am going to draw data which relationship between the population and the number of years in Canada. So this is not might be the exactly data from the stat office, but just to explain this topic. So let's see if the population I draw is like this. So let's say I have years, and the years I have is 1950s, then 60, 70s, 80s, 90s, and 2000, like 90, 2000, 2010, 2020. So on this side, I have 5, 10, 15, 20, 25, 30, 35, 40, 45. So this population is in millions. So we are talking about in millions, and these are the number of years. So let's say in 1950, the population was just under 15 million. So if I have to count, then I might go and find out a dot right at this spot. So I should not be, I'm not going to just draw these numbers, but I'm going to just take this one off. And the reason I am taking this off so that it won't confuse viewers or the students where the number are coming from. Now the next dot I have is in 1960s, the population was just in between 15 to 20, and the graph is showing me that somewhere about this position. So might be around this number. So that was in 1960. Then in 1970, it was just shy of 25 million. So if I have to go in 1970, so this might come up somewhere if I have to go this way, and then it might come up around this number. Then in 1980s, it was just over 25 million. So in 1980s, if I go this way and then I'm coming at this part, that means it might be somewhere at this number. In 1990s, it was just over 30 million. So I'm going to go 90s, it's just over 30 million, might be somewhere around this part. Then in 2000, it was 35 million. So 2000 coming this way and 2000 coming this way is giving me a spot right here. So I should be using a different color so that people won't get confused. So the reason I picked up this was this number, this, then I'll just move a little bit down. So if you see these numbers, so now when we see these numbers, I'll show you one more number I have. It is giving me in 2010 was about 40 million. So let's say 2010 was going all the way this, and this 2010 is going all the way this. So I was getting this part. In 2020, it's just sorry, in 2000. Yeah, so they have this only data. So now, if I wanted to see that what kind of pattern I am getting, so when I see these numbers, now when I draw this line, I can easily see that this data is actually giving me a straight line. So I can call it a linear. Linear means they are increasing in the proper format, and I'm getting a straight line. So if I have to put a ruler, and let's say if I put a ruler like this, then I can easily draw. There might be some number if I exactly put a ruler. So might be one number a little bit slightly up or down, but it overall it gives me a pattern. So if I have to go this way and put a ruler here, so I can easily draw a line. So I can draw a line like this. So now if you see this point was a little bit higher than actual straight line, just over, or any other number could be slightly over, slightly down. So these numbers showed me that the best fit line or best fit pattern was coming exactly a straight line. So this is what it means, that constructing a lines or curves of the best fit. Even if I have some numbers up or some of the number a little bit down, but I need to see majority of the numbers are giving me a pattern, I can easily call them that yes, I draw this, I construct this line from the best fit numbers, and after reviewing this line, I can say that this line outcome is a linear straight line. Now in this form of curve, I can give you an example that how the curves come out. We call them non-linear relations. As non-linear relations form the curves, a line to the best fit cannot be drawn. Instead, a curve of the best fit is drawn. Again, not all the points must lie directly on the curve, but the curve should reflect the trend of the data. So in this curve, when we are talking about the curve, as I just said, might be all of the points, just like in the linear relations, they are not coming exactly on the line. And exactly when we draw the curve, you might see many of the points or some of the points are not going to be on the curve, but majority of the points are going to be on curve. So let me draw a curve now. Somehow this is not actually rubbing clearly, but I am going to draw this curve, and simply the curve is going to be like this. So if I have a straight line this, and if I have a data which I am going to draw, and the data is, say, for example, between the time and the speed, representing a scatter plot between the time and speed, then I might have time going like 5, 10, 15, 20, 30, 40 seconds, 5, 10, 15, 20, 25, and 30 seconds. And then I have speed. So I can say 100, 200, 300, 400. So 100, 200, 300, 400. So in this case, I am going to say that if I have, speed versus time tracking, and my first dot was coming up at this number, regardless of going into the detail, let's say that I have two data which were giving me that in 5 seconds or 5 hours, I will be able to cover this 190 kilometers. Then the next was, say, in so the next number was coming up this way, this way, this. So if I have a draw these dots, and if I come and try to draw the numbers, and then I can say that my graph is coming up this way. Some of the points might be coming out, and that shows me that if I have a relationship, I have the numbers to draw on this graph, and I see majority of them are giving me a pattern, but they're not coming in a straight line, and I am getting a curve. So I am actually constructing a curve or the best fit. So what I did, I left some of them which are going away, but I tried to draw the closest possible curve I could have drawn. So this is an example of constructing lines and curves out of our coordinates given, or any data collection, where we sometimes get a line, sometimes we get non-linear relations, which gives us a curve. So this was the topic of the day today. I hope that today's session is a little bit smaller. I have another event. I would like to invite everybody to join William Osler's Canadian Pakistani Friends of William Osler Eid Festival, starting shortly after this. I have to get ready for that event, but I wanted to continue my commitment with math class. So I was able to cover up this topic today. I hope that the students, the parents who are interested in watching this are able to get some benefit and understanding about constructing lines and curves of the best fit from the coordinates or the points given. Feel free to contact me at 416-571-1163, or you can send me messages if you have any question or if you have any difficulty in understanding this particular topic or any other topic. I'll love to help you. I will try my best to help as much as I can, and try to utilize my time in helping the community, helping the students in mathematics. So I hope that something was covered today, in a sense that people were able to get some understanding and some learning after this session today. And enjoy and happy Eid to everyone who is celebrating. I am celebrating. Today is our third day of the Eid, so happy Eid Mubarak to all of you. I hope that you are enjoying Eid, and rest of everyone who is not enjoying Eid, enjoy your Sunday. A little bit cloudy, but still it's a wonderful summer Sunday. Thank you and have a wonderful weekend.